Untuk soalan yang seterusnya, a 200 kg wooden disc of radius 3 meter is rotating with angular speed of 4 radian per second about the rotation axis. So it's given the mass, the radius of the disc, and the initial angular velocity of the disc about the rotation axis, which is at the center, as shown in the figure. A 50 kg bag and then a 50 kg bag of sand falls onto the disc at the edge of the wooden disc. So dalam diagram ni dia dah mention before and after. So before, the wooden disc is just rotating, okay, with angular speed of 4 radian per second. Later, okay, in the diagram you can see this, there is an object was put here at the edge of the disc, which is a 50 kg sandbag. So this is the 50 kg of the sandbag mentioned in the question. So there is a before and after diagram. So it's easy for you to imagine the situation. So in order to calculate this, we're going to use same as before. The summation of initial angular momentum will be equal to summation angular momentum final, and it's given by I initial omega initial equals to I final omega final. Okay, and then we need to consider that initially there is no sandbag, but after, the moment of inertia of after would be altered, would be different, because we need to consider the moment of inertia of the sandbag. Okay, so first we just need to calculate the moment of inertia initial equals to, we calculate it separately. It's just this, which is we're gonna use what's given in the question, which is I for the disc will be half mr squared. So half mr squared, which is the mass of the wooden disc, is 200 times the distance. The radius of the wooden disc, which is 3 meter square. So we will get equals to 900 kg m square. Okay, and then for moment of inertia final, it would be from the sand. Okay, moment of inertia of the sand plus the moment of inertia of the disc. So we've calculated that the moment of inertia of the disc is 900. We're just going to add that up. But for the sandbag, we're going to use, as before, we're just going to use the point of mass formula, which is mr square plus 900, which is the mass of the sandbag is 50, and the distance of the sandbag from at the edge to the axis of rotation is the radius, which is 3 square plus 900. So it's going to be 900 plus 450. Then we're gonna add that into the equation to find. So this one will be 900, which is the omega initial is equals to 4, equal to I final, which is 900 plus 450 omega final, and you will get the angular velocity after the sandbag has been dropped, which is 2.67 radian per second.